We now discuss how to transpose a partitioned matrix. We again start by considering a concrete example. Here is a 3x4 matrix A and its transpose. Let's partition these matrices. Notice how the partitioning of A propagates into a partitioning of A transpose. We introduce some color to help highlight the blocks of A and how they relate to the corresponding blocks of A transpose. Compare A transpose at the bottom to A to its left. You notice that the contents of the bottom left block have been exchanged with the contents of the top right block. Next, compare A transpose at the bottom to A transpose above it. You notice that each block itself has been transposed as well. This illustrates a general principle. If you partition a matrix A into submatrices, then its transpose is obtained by first transposing the matrix of blocks as if the blocks are just elements, and then transposing each individual block. What if each block is just an element? Then the general principle is to transpose the matrix of elements and then transpose each element. But because the transpose of a scalar is just that scalar, you get the transpose of the matrix as we had already encountered earlier in the course. Now let's look at some special cases. Partition the matrix by rows. The ith row is denoted by a tilde sub I transpose. Here the transpose is part of the label for the row, since it is a vector column that has been transposed, making it a row. The general principle says that you transpose the matrix of submatrices, and then you transpose each submatrix. So, you transpose the matrix of rows, and then you transpose each row. But that then yields a matrix of columns, where each column in A transpose is just the transpose of the corresponding row in A. You can do exactly the same thing with a matrix that has been partitioned into columns. The result is a matrix of rows, where each row equals the transpose of the corresponding column in the original matrix. A case that we will use and abuse this week is the case where a square matrix is partitioned into a 3x3 matrix of submatrices. If you apply the general principle, you see that submatrix Ij in A becomes submatrix Ji. To summarize, how do you transpose a partitioned matrix? You view each submatrix as if it's a scalar. You transpose the matrix as you would a matrix of scalars. But then you have to transpose each of the submatrices.